Welcome friends in lecture 6 science lesson 12 electricity. Fine, in today's lecture we are going to learn about the series and parallel circuits. Now series and parallel circuits of resistors, which are actually this is an arrangement of resistors in series connection and in parallel connection. So what is the difference? As you are seeing in the diagram on the picture, that you are able to see in the first in the series connection as written in after property series connection of a resistors in circuit, and the next column is parallel connection of a resistor in circuit. In diagram itself you are able to see the difference, that all the in series connection resistance R1, R2, R3, R4, here you are seeing it is connected with voltage. Voltage is nothing but a source from which the current is supplied. So this is, as we have already studied in circuit diagram, this is the same circuit diagram, but this is an only series circuit diagram with more than one resistance. In the next form, so you may see here that as the one connection is getting over, that is from A to B, you are able to see that as one resistor is getting the starting of first resistor and the end of the first resistor, the second resistor starts. Fine, and the second resistor end starts with an third resistor. That from C the R3 starts, and from D, that is an end of the third resistor, the fourth resistor starts. Fine, so this is how the resistor connection is there in terms of series. In case of parallel connection, you are able to see all the resistors are having the common starting point, that is A only, and all the resistors are having the common ending point, that is E. Fine, in the circuit diagram also you are able to see two bulbs, that we are able to see in here the two bulbs are there. In these two bulbs are connected in series from end of the first resistor to the second resistor starting. In case of parallel connection, you are able to see both the bulbs having are resistor as a resistor are having the common starting point and common ending point. Now in potential difference, the potential difference across the combination of the series resistor is a sum of potential difference. Why? Because every individual bulb, as we are seeing in the circuit, from here both the bulbs are, or we can say individual resistor R1, R2, R3 and R4, all of them are having different potential difference. That is, the potential difference is going to get dropped. For an example, we are having 220 volts, and if you are connecting a bulb, two bulbs in connection, that each of them are going to divide by 2 as an 110 volts if they are equal bulbs. But in case of parallel connection, potential difference across the combination of parallel resistor remains constant across the individual resistor. That is, each and every resistor in a parallel connection, that is all are having starting same point, must be having same voltage. So we can say that total voltage in the circuit is equals to the individual voltage in each and every resistor, that is V is equals to V1 is equals to V2 is equals to V3 and is equals to V4. You may write down that way. In terms of current, it is exactly opposite to it. The current across the combination in series resistor remains constant across the individual resistor, that is I is equals to I1 is equals to I2 is equals to I3 is equals to I4. But in case of parallel connection, you may see that the total summation, the sum of electric current across the individual resistor, I is equals to I1 plus I2 plus I3 plus I4. That means the total current is divided, and here the total current remains same. But in case of in series connection, that we can say that voltage divides but currents remain same. But in case of parallel connection, voltage remains same and current divides. So the wherever the current divides, then that will be the income come in the summation part, that is I1 is plus I2 plus I3 plus I4. And here in case of the series connection, current remains constant. In short, you may remember PV and SI. PV means parallel voltage is constant, and in case of series, current is constant. Parallel voltage is constant and series current is constant. Right? So you may learn this way and remember one only, because if you are going to learn both of them, you are going to forget both of them. So learn one, that is, in case of parallel connection voltage is constant, so V1 is equals to V2 likewise, and in case of series connection current is constant, that is I is equals to I1 is equals to I2. Now the another important part is equivalent resistance. In case of an equivalent resistance, V is equals to IR, that we know according to Ohm's law. In the similar, V1 will be equals to IR1 and so on. So here the current remains constant in all, V2 is equals to IR2 and I does not change, but V is changing. So the total voltage will be V is equals to V1 plus V2 plus V3. In the same way for 3 resistor we are taking, so I equivalence, so R equivalence will be equals to IR1 plus IR2 and plus IR3. So cancelling I from both the sides, taking it out common, we get R1 R equivalent. Equivalent means the total summation of the resistance will be equals to R1 plus R2 plus R3. Whereas in opposite case, in parallel connection, according to Ohm's law, in the same manner, I will be equals to V1 upon I1 will be equals to V upon R1, I2 will be equals to V upon R2. Here, so here voltage is constant. Fine. Here everywhere you may see I V upon R1, I2 V upon R2. Here the voltage is constant. So taking summation of all the current, that is I is equals to I1 plus I2 plus I3, keeping in the equation for 3 resistor, V upon R equivalent will be equals to V upon R1, V upon R1 plus V upon R2 plus V upon R3. Taking cancelling V, taking it out common from both the opposite left hand side and right hand side, we get 1 upon R equivalent is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on. Fine. So we will take one experiment also and try to understand this out. This connection here on the screen. Fine, and in this series connection you may see this series diagram. This series diagram we are connecting the 3 bulbs. This is a bulb, 1, 2 and 3 bulbs. One is having a blue wire and one is having a yellow wire. So we are connecting one blue with one yellow and another blue with another yellow, that is end of first resistor, that is in starting of the second one, and so on. And after connecting all of the 3, we are going to start the electrical circuit, and you may see this is an wire, the green wire in yellow wire, right, and we are going to connect it and we are going to see how the bulb is lighting. So you are able to see that the 3 bulbs are getting light on up, but the light of the 3 bulbs is not that enough. If you measure this out, the total voltage is 250, and if you individually measure the voltage in each of them across the resistor, that is all of the 3 as an individual, you may see that the voltage is divided by 3, that is here we are able to see the total voltage as 250, but in case of individual voltage you will be able to not see the same amount of voltage across the individual resistor. Fine. So if you measure this, if you are measuring in each of them, the total was 250, but here the voltage you are seeing as 70 around, that means 250 divided by 3 is approximately 75 something odd around. So you will able to see the 75 voltage across it. Fine. 1, 2 and 3, you are able to see 70 something odd around, 72, 75. Thus because this is the voltage across each resistor, that is R1, R2 and R3. Now in the same way, if you are seeing the parallel connection, this is a parallel connection, all of them are going to start with the same point. So all the 3 bulbs we are going to connect with the same starting point. See the connection of all the yellow in one section and blue in one section. So after connecting it, all the 3, all of them are having same starting point and same ending point, and connecting these wires with the same starting point and same ending point, each one is going to have equal voltage, and you may see the equal bright bulb shining. So you will be able to see these all the 3 bulbs are shining very nicely with a 250 voltage, where in case of, and the voltage total across you are able to see is 250, and individual voltage see measuring gets 250 only in the multimeter, 250 voltage again, right. So that shows that each of them are having the 250 voltage, that means voltage is not dropping. In case of parallel connection is remaining same, the current drops out. Fine, I hope so you must have understood from this particular video about series and parallel connection.